Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Walking robot simulation, Leetcode 874. In this problem, we have a robot on an infinite xy plane starting at point 0, 0, facing north. The robot can receive a sequence of these three possible type of commands. -2 means to turn left, -1 means turn right, and value k means move forward k units, 1 unit at a time. Some of the grid squares are obstacles. The ith obstacle is at grid point obstacle I is equal to xi yi. If the robots run into an obstacle, then it will instead stay in its current location. Then we should return the maximum Euclidean distance that the robot ever gets from the origin squared. That is, if the distance is 5, we should return 25. So xy plane means x runs horizontally and y runs vertically, right? And north corresponds to the positive y direction. East corresponds to positive x direction. South corresponds to negative y direction. And west corresponds to negative x direction. And there can be an obstacle in point 0, 0 as well. Now in example 1, we are given commands as 4, -1 and 3, and there are no obstacles. Then robot starts at point 0, 0, also called origin, facing north. Then first command it gets is 4, so it moves 4 unit forward in the direction of north. So it comes at point 0, 4. Then it gets a command -1. So -1 means to turn right. So it will now face in east direction. And then it gets the command 3. So the command 3 then moves it forward 3 units in the direction of east at position 3, 4. By 3, 4 we mean x is 3 and y is 4, right? Now the farthest point it is from point 0, 0 or origin is 3, 4. So here it was 4 distance away and now the robot is 3 square plus 4 square distance away. When we calculate the Euclidean distance between two points with coordinates x1, y1 and x2, y2, then the formula is x2 minus x1 square plus y2 minus y1 square, and then we take the square root of it. But here they want us to return the square distance itself rather than taking a square root of it, most probably to avoid floating point values. Here we know that one of the point is always origin, so the formula becomes x2 square plus y2 square. So that's why the distance here becomes 3 square plus 4 square is equal to 9 plus 16 is equal to 25, and that will be our answer. Now example 2 is more interesting one because it has obstacles as well. Now let's clean it up. So now it is given that there exists an obstacle at 2, 4. So let's mark that one. So robot cannot pass it. Initially the first command is 4 and robot is at origin facing north direction. So it will move 4 units forward in the north. Then it gets -1, that means to turn right. Now it is facing towards east. Then it gets the command 4. So now it has to move 4 units forward in east. So when it starts moving, it comes to 1, 4 and then it tries to go to 2, 4, but it gets blocked by obstacle there. So now it is stuck at 1, 4 and now it gets the command -2. That means it has to move towards left and it is currently pointing towards east. So it turns left and faces north. And then another command it gets is 4. So it will move 4 units in the north. Let's call this one point as an 8. So now it is at 1, 8 and it is the farthest point from the origin. So it will be 1 square plus 8 square equal to 65, and that will be our answer. Now in terms of solution, we will start by defining an array of directions and an obstacle set for quick lookups. Then we initialize the robot starting point as origin, that is x and y is equal to 0 and direction as north. And then for each command, we will adjust the direction for turn commands and move forward step by step for movement commands, checking for obstacles. And whenever we are able to move, we will check if it is the farthest point. If it is, then we update our maximum squared distance. And finally, after all the commands, we will return it as an answer. Now, when we are solving the problems involving directions, I use these directions array quite often. And you can see many problems on this channel as well, where we are using this array. Each tuple represents a unit step in the corresponding direction, north, east, south, and west. Now initially robot is facing north. If it gets the command to move k units forward, it will move in north by increasing the y coordinate k number of times, unless of course it hits the obstacle, because only coordinate which changes is y, and that too with positive value. Similarly, if we are facing towards east and we have to move k units forward, then we move in east direction by increasing x coordinates k number of times, because now x coordinate has a positive unit value. Similarly for west, x has negative unit value, and for south, y has negative unit value. So this was easy. And now for direction change, suppose we were again facing north, and let d be the index of the current direction. So that means d is equal to 0 for north. And now we got the command to turn left. So that means we have to now face west. So in terms of index in the directions array, we were at 0, but now we came to index 3. So that means if we go clockwise, that is we start from 0, then 1, 2, 3, then we have to select the fourth direction, counting from itself. So that's why we add 3 to the index, and then we do the modulo operator to keep the index within the bounds of the directions array. Or we can also do direction index -1 modulo 4, because then we go counterclockwise. But if you go clockwise, then we have to do +3. So this is up to you. Similarly, if we are facing east and we have to turn left, that means we now will face north. So we start counting from east. So it will be 0, 1, 2, and 3. So that means now we will face north. So regardless of the direction, if we go left, we have to select the fourth direction counting clockwise, or we have to do direction index -1 if we go counterclockwise. Similarly, if you have to turn towards right and suppose we are facing north, then this time we go to east. So we have to just select the next direction. So we just increment the current direction index by 1 and do the modulo 4. Now rest of the things will be clear once we write the simulation code. So let's first convert the obstacles to the hash set for faster lookups. Sometimes I use this technique to convert a coordinate or some other object into the string to store it as a key in the hash set or hash map, because then we don't have to worry about implementing equals and hashcode methods, as the built-in string class in Java already has it implemented. So only thing we have to ensure is that the keys should be such that we don't get any collisions. Otherwise, we will get the wrong answers. So here we can take x comma y, or we can put a dash, or we can put an arrow. So up to you. Now we define our directions array. So first we define north, then we define east, then we define south, and finally west. Now our initial direction index will be 0 because we start from north. Our initial x and y coordinate will be 0. And our initial answer, that is max distance square, will also be equal to 0. Now we will start processing the commands. So if command is -1, that means we have to turn right. So we just pick up the next direction clockwise. So our new direction index will be direction index +1 modulo the size of directions array, that is 4. Similarly, if command is -2, then we turn left, and our new direction index will be direction index +3 modulo 4. Else, now we have to start moving, right? So our change in x will be x coordinate of the current direction. Similarly, change in y will be y coordinate of the current direction, because we have to go step by step. So initially our number of steps will be 0. Now we will move step by step until we have moved k units from command, or we have hit the obstacle. Now our next x position will be whatever is our current x plus change in x. Similarly, our next y position will be whatever is current y plus change in y. Now we check if the next position is blocked by obstacle. So we will again convert the position to string key. So it will be next x comma next y. So we check if obstacle set contains the next position. That means we can break out of the loop because we can't move forward. Otherwise, we change our x to next x because now we can go there, and similarly y as well goes to next y. And at each point we calculate our maximum distance square. It will be maximum of current max distance square or distance square based on the current position. So it will be x square plus y square, because we have to always calculate it from origin, and increment our count. Finally, we just return the answer. Now let's run this code. Cool, let's submit this code. Cool. In terms of time complexity, it will be O of O plus C, where O is number of obstacles and C is number of commands. Because first we go through this obstacles array and create our own hash set, so that now whenever we fetch the obstacle, that takes O of 1 time. And then we run the commands array that again takes O of C time. So that's why the time complexity is O of O plus C. And in terms of space complexity, it will be O of O because we are storing these obstacles in a set and that requires extra space. So that's why it is O of O. I hope this video was useful to you. If it was, please give this video a thumbs up and consider subscribing to our channel for more tech content. If you have any questions and suggestions, please feel free to write in the comment box. Thanks for watching and see you next time.